Hello friends, welcome to online lecture series. Today we will see the next topic of linear differentiable equation. Today we will just cover the topic linear differentiable equation of first order. Before we start today's topic, we know what is the mean by differentiable equation, how to find its degree and its order. So the linear differentiable equation of first order is, the differentiable equation is linear differentiable equation if the differentiable equation contains the dependent variable y and its derivative whose degree is 1. But the condition is that the product of your dependent variable and its derivative should not present in that equation. Then is said to be the linear differentiable equation. Definition of this linear differentiable equation is said to be the differentiable equation is said to be linear differentiable equation if the dependent variable y and its derivative, that is dy by dx, occurs in first degree. Means the degree of your variable y as well as degree of your dy by dx is 1 and are not multiplied together. It means the product of your y dy by dx should not present in your differentiable equation. For example, the differentiable equation x dy by dx plus 2y is equal to 9x square is my linear differentiable equation, because this differentiable equation in which dy by dx is present and variable y is present, both particular dependent variable and its derivative whose index is 1. Also, there is no product between your y and dy by dx, so it is your linear differentiable equation. This is example number second. In example number 7, what happens? The y variable is multiplied with dy by dx. It means the product between your y and dy by dx is present. Due to the product between dependent variable and its derivative, the differentiable equation is not linear. So the example number 2 is not a linear differentiable equation. So the differentiable equation is linear and not a linear. It's very simple to identify. The dependent variable whose coefficient, whose index should be 1, as well as the dy by dx, that is a dependent variable's derivative whose index is also 1. If this condition is occurs, then we said that the linear differentiable equation is linear. Then according to the dependency concept, means if y is dependent, then we have one type of solution, one type of equation, and that equation have solution. If x is dependent, we have the second type of differentiable equation. The linear differentiable equation can be generally classified into two different forms. The form number first is the differentiable equation is dy by dx plus py is equal to q. Then this differentiable equation is said to be the linear differentiable equation, but there are 3 different particular cases. Means we set the conditions. The dy by dx whose coefficient should be 1. Again, p and q are the functions of your x variable and index of your y variable is 1. If these 3 conditions are true in this differentiable equation, then it is my linear differentiable equation in y variable. Then we can find its integrating factor. The integrating factor of such a linear differentiable equation can be found. The integrating factor is equal to e raised to integration p into dx. Then the general solution can be found with the help of the solution of the given differentiable equation, that is y is my dependent variable. We have to find a solution. Y into integrating factor is equal to q into integrating factor whose integration with respect to dx plus c. This is the general formula to find the general solution of the linear differentiable equation in dy by dx. In the similar way, if x is my dependent variable, then we get a second form of linear differentiable equation, and that can be defined by dx upon dy. So dx upon dy plus px is equal to q is the linear differentiable equation in x variable. So we can find its condition. Again, the index of your x variable is 1. Again, p and q are the function of y or some constants, and the coefficient of your dx upon dy is 1. If these three conditions are true, then the given differentiable equation is a linear, and we can find its solution by finding its integrating factor. The integrating factor of such a differentiable equation is given by integrating factor if is equal to e, whose integration is p into dy. And the general solution is given by, the x is my dependent variable, so x into integrating factor is equal to integration of your q, that is the right hand side, into integrating factor dy plus. After replacing the value of integrating factor, we get a solution of such a differentiable equation x into e raised to integration of p into dy is equal to integration q into integration of p dy is the index of your exponential function dy plus c is the way to find the solution. So we will see example of this type, then we will get the clear-cut idea regarding to linear differentiable equation. So differentiable equation is given here. They told us solve x cos dy by dx plus cos x minus x sin x, which get multiplied with y is equal to. It's a linear differentiable equation. We have to find its solution. For that, we have to represent the given differentiable equation as it is. But the differentiable equation is not in the form of. The differentiable equation contains dy by dx. It means it is a very easy to make the conversion of this differentiable equation into linear form, and the linear form is dy by dx plus py is equal to q. When we compare the given differentiable equation with our linear differentiable equation, then we observe here the coefficient of your dy by dx is get multiplied with x cos x. It means it is necessary to make the conversion of your dy by dx in terms of 1. So we have to divide the entire differentiable equation by x into cos x. So by dividing the differentiable equation by x cos x, we get dy by dx whose coefficient becomes 1 because x cos x upon x cos x becomes 1. So we can say that can be is here. After just dividing the whole differentiable equation, this is the actual scenario. Means x cos x dy by dx, which get divided by x cos x, then x cos divided by x cos x minus x sin x divided by x cos x is get multiplied by y. The right hand side is also get divided by x cos x. After making the simplification, the x cos x, the coefficient of your dy by dx becomes 1. Again, the cos x get cancelled from the second terms. The remaining term is 1 upon x. Again, x get cancelled. Sin x upon cos x becomes tan x. This is the linear differentiable equation in y. It's in the form of dy by dx plus p times y is equal to q. When we compare with linear differentiable equation, the value of your p, this is the given differentiable equation form, then we got the value of your p. The p is equal to what? The p is equal to 1 upon x minus tan x. And the q is equal to 1 upon x cos x. Then we have to find the integrating factor. The integrating factor is nothing but we have to take the integration of your p with respect to x, and that integration is nothing but the index of your exponential function. So we get the integrating factor in the form of e raised to integration of p with respect to x. So replacing the value of your p, and value of your p is 1 upon x minus tan x. And we know that integration of 1 upon x is log x, and integration of your tan x is log of sec x. So we get this integration after taking the integration e whose power is log x minus log of sec x. Again, we know that log a minus log b is nothing but log a upon b. According to that log rule, just exponential function's index becomes log x upon sec x. Then we know that again the log is the index of your exponential function. E whose power is log x becomes x. So we got the integrating factor of such a differentiable equation is x divided by cos x. It may be converted into, because 1 upon sec x is nothing but your cos x. So we get x cos x is my integrating factor. So to find the general solution, we have to just multiply the integrating factor to its dependent variable, and we have to just multiply your right hand side by integrating factor taking its integration with respect to x. So y into integrating factor is equal to q into integrating factor dx plus c is the solution of differentiable equation. Replacing the value of your integrating factor, that is y into x cos x, is equal to integration of 1 upon x cos x. This is the value of your right hand side, that is the value of your q, and your integrating factor is x cos x. So x cos x get cancelled from your numerator and denominator of the denominator in this integration. So v remains x, that is the dx. So y x cos x is equal to integration dx plus c. After taking the integration of your x, dx is x. Then the final solution is your y x cos x is equal to x plus c is my general solution of this differentiable equation. We will see the next example. The next example is again based on your linear differentiable equation. They told us solve 1 plus sine y. This is the coefficient of your dx upon dy is equal to 2y into cos y minus x in bracket sec y plus tan y. Means this differentiable equation is given and we have to find its solution. For that, when we observe the differentiable equation containing dx upon dy, it means it is a very easy to make the conversion into linear differentiable equation, that is dx upon dy plus p times x is equal to q. To make the conversion of this differentiable equation in dx upon dy, the coefficient of your dx upon dy is 1 plus sine x. So we have to divide the entire differentiable equation by 1 plus sine x. So dividing the differentiable equation by 1 plus sine x, we get this 1 plus sine x divided by 1 plus sine x get cancelled. So we will mention here 1 plus sine y, we have to divide with this 1 plus sine y, it's divided, it becomes 1. Again 2y cos y, 1 plus sine y. Again, then in the next term, x into sec y plus tan y. Then we have to make the simplification. 1 plus sine y get cancelled from the coefficient of dx upon dy. This is your linear form. The linear form, we have to make the conversion of your that. So after making the conversion, the dx upon dy is equal to 2y cos y, 1 plus sine, this term remains as it is. Then minus of x, we know that sec x is nothing but 1 upon cos. Again tan y is nothing but 1 upon cos. cos of sine upon cos. So then cos, it is nothing but your that's a numerator becomes 1 plus sine y. After making the simplification of this, we got the new particular simplified form of this dx upon dy is the dx upon dy is equal to 2y cos y 1 plus sine y. Again, the denominator of these two terms are same. We have to make the summation of your numerator. So it becomes x into 1 plus sine y divided by cos y, and whole terms divided by 1 plus sine y. So 1 plus sine y get cancelled. We get x upon cos y in the next term. And we have to make the simplified form of this differentiable equation. And we have to just make the changes. We have to shift this x cos y to the left hand side. So differentiable equation is into type number second. This is the form. When we compare with our given differentiable equation in the standard form, then we get a value for p is equal to sec y, and q is equal to 2y divided by 1 plus sine. This is the given differentiable equation in the form of dx upon dy plus px is equal to q. When we compare this, we get a value for p. The value for p is equal to sec y, and value for q is equal to 2y cos y divided by 1 plus sine y. Taking the integrating factor, integration of your p with respect to y, it's index of your exponential function e raised to integration of your sec y, and we know that the integration of your sec y is equal to log of sec x minus tan x. So we get this. Again, the index rule of your exponential function, we get sec y plus tan y is the solution of my integrating factor. And lastly, we have to find its solution. Solution can be found by multiplying your dependent variable, that is x, by integrating factor is equal to the right hand side into integrating factor, and its integration with respect to y variable, and plus c the constant of integration. So we got this x cos x into sec y plus tan y. On the right hand side, the q is nothing but 2y cos y 1 plus sine y. Again, sec y plus tan y is my integrating factor dy plus c. Again, we know that sec y is nothing but 1 upon cos, tan is nothing but sine upon cos. So we have to make the simplification again here. We can make the simplification. After simplification, we get this 1 plus sine y divided by cos y get cancelled with its 1 plus sine y. One plus sine y, this 1 plus sine y get cancelled, cos y get cancelled. We got only 2y, and we have to take the integration of your 2y with respect to y variable. This is the simplified form after cancelling 1 plus sine y and cos y. And integration of your y is y square upon 2. That 2 get cancelled. We get a final solution of this differentiable equation. That is x into sec y plus tan y is equal to y square plus c is the general solution of the given differentiable equation, which is solved.